Hello guys, welcome back. This is Dr. Hadi here, and today we are having another interesting lecture, that is enzyme kinetics. What is enzyme kinetics? We will discuss this and the effect of substrate concentration on the rate of reaction. We will also study what is mean by the word rate of reaction. So I will start my lecture with the rate of reaction before we go into the depth. Enzyme kinetic studies are not only important for the students of the lower grade, but also for those who are doing M.phl or PH. This is a really very interesting topic. In this topic, we will also study the subheadings which are involved in this video lecture are mechanism of enzyme action, initial velocity or initial rate. What is mean by this? Maximum velocity or maximum rate, order of the reaction, and the study of all this stuff by the help of a graph. Without graph, the study will be having no value at all. So I will share the graph with you in this lecture. Okay, as I mentioned that, first of all, we must know what is meant by the word rate. Rate means if you are doing something with respect to time. Let's suppose you are walking 3 steps, 1, 2, 3 in 1 second. So this is your rate. You are covering a distance of 3 steps in 1 second. 3 steps in 1 second is your rate. If you are walking and you are covering 5 steps in 1 second, so 5 steps in 1 second is also your rate. Rate is a word that can be used in different field of life. But in case of enzyme, what is mean by the rate of enzyme? Actually, this example will be quite enough. Before we study the rate of enzyme, I would like to tell you the generalized concept that an enzyme react with a substrate. This is substrate, this is enzyme, react, and as a result, what will be formed? Enzyme substrate complex. Enzyme substrate, enzyme substrate complex. This is called enzyme substrate complex. And I would like to draw here a star because this is a really very important thing, enzyme substrate complex, that I will tell you why this is really very important in upcoming video. This reaction is reversible. When enzyme combine with the substrate, then enzyme substrate complex can be formed, or enzyme substrate complex can be dissociated back, broken down back into enzyme and substrate. So it's a reversible reaction. Then enzyme and substrate. Enzyme will catalyze the substrate into product P. This is the product, and this is enzyme is now free. Enzyme is now free because it has done its job. So this enzyme complex is very important. We had substrate that finally become product. Substrate finally become product. This is our purpose. This is our target. Who did this? By the help of enzyme. Okay, now let's suppose we have 10 enzyme. These red squares represents enzyme, and the green dots, they represent a substrate S. Let's suppose we have 2 substrate. What will happen? For 2 substrate, one substrate will be attached at that enzyme and other will attach at the second enzyme, right? So yes, now you can see here we had 2 substrate. These 2 substrates are binding at 2 enzymes, and these 2 enzymes will catalyze the substrate into product. So what will happen? We will get some product. But if you see here, how many substrate molecule catalyzed? How many? 2 molecules. So 2 molecules were catalyzed. Of course, they formed enzyme substrate complex and then they converted to product. So 2 molecules converted into product by the help of enzyme in, let's suppose, in 1 second. Let's suppose 1 second. I can write 2 molecules in 1 second, 2 molecules per second. This is our rate. Finally, we got what is meant by the word rate of enzyme reaction. Rate of enzyme reaction means how many substrate molecules are converting into product in a unit time. 1 second, 10 seconds, or 1 minute. It's okay. This is the time. These are the number of substrate molecules. So 2 substrate molecules are converting into product in 1 second. This is called the rate of enzyme. If you have 3 substrate molecules, let's suppose 1, 2, 3 substrate molecules, then one substrate will come at that enzyme, another substrate molecule will come on that, and the third substrate molecule will come on the third enzyme. So among all of these enzymes, only 3 enzymes will be utilized. Only 3 enzymes. Why? Because only 3 substrates are available. So for 3 substrate molecule, out of 10, only 3 enzymes will be utilized. So 3 enzyme substrate complex will be formed, and 3 substrate molecules will be catalyzed in 1 second. This time we say the rate of reaction is 3 molecules per second. Similarly, you can go for 4 molecules, 10 molecules, 100 and 1000 and thousands of lakh, 10 lakh molecules per second. In reality, the rate of enzyme is really very fast. It is not in 100 molecules per second, 1000, 1 lakh, 2 lakh, more than lakh. In lakh, the rate is in lakh. Okay, it was just to clear the idea of what is the rate of reaction. Okay, once we got what is the rate or speed of the reaction, then we have initial velocity or initial speed or initial rate. This is nothing, same thing. Initial velocity or initial rate, same thing. Okay, various factors control the rate of reaction. Every enzyme has a reaction rate. Every enzyme has reaction rate. Definitely there are some other things that control the rate of reaction. Means if you increase one parameter, what will happen to the rate of reaction by increasing that parameter? Now what is parameter? Parameter could be temperature, could be pH. Means if you increase the temperature, what will happen to the rate of reaction? Either the rate of reaction also increases or decreases. Similarly, you can also make a relationship between the rate of reaction and the pH. If you increase or decrease the pH, what will happen to the rate of reaction? A kind of relation is being developed between the rate of reaction and the external parameters like pH, temperature. You know, the most important parameter that we are going to discuss in this video lecture is not the pH, is not the temperature, but the substrate concentration. In this video lecture, we will check what happens to the rate of reaction by changing the substrate, by either increasing the substrate or decreasing the substrate. What will be the effect of this change on the rate of enzyme? Either enzyme speed increases or decreases. This will be the today's most focused point. The study of this phenomena means the study of what? The study of effect of parameters on the rate of reaction is called enzyme kinetics. Determining the rate of reaction and how it changes in response to the experimental parameters, or the effect of change of experimental parameters on the rate of reaction is called enzyme kinetics. So different factors we have that affect the enzyme action. एंजाइम के रफ्तार को मुख्तलिफ फैक्टर्स कंट्रोल कर सकते हैं, लेकिन एक इंपॉर्टेंट फैक्टर, वन इंपॉर्टेंट फैक्टर is what? Is the substrate concentration. Okay. Now, after we got the rate of reaction and the enzyme kinetics, we will come to discuss the initial velocity or the initial rate. The word initial velocity we have heard in physics. Initial velocity, final velocity. But this time the scenario is quite different. Here you will not use final velocity or initial velocity. Here the initial velocity is something else. My first question is that in biochemistry, in the chapter of enzyme, why the word in initial velocity has come? Why we use this initial velocity? What compelled a scientist, a biochemist, to use the word initial velocity? Come to me. Before we go to the idea that why it came to us, I will let you know what is meant by initial rate or initial velocity. Actually, when you start a reaction, it will start from 0 second to 10 second to 100 second to 2 minutes to 3 minutes to 5 to 10 to 15 to 30 minutes. The reaction once started can go on. If you check the rate of reaction in the first 60 seconds, the first minute, this rate will be called initial velocity or initial rate. Okay, so you should not go into the second minute or the third minute. Whatever reaction rate an enzyme has in the first minute, this will be called as initial velocity. Now come to the concept, why as chemists use this word initial velocity. So the initial velocity is used to get some purpose. The purpose. What is the purpose of using this initial velocity? Actually, if we link the rate of reaction, and the substrate concentration, these two things we have, there is some complexity. Complexity means you cannot study the rate of reaction properly in relation to substrate. Why? Because the substrate is changing. Because the substrate is changing. Because the substrate is changing. Once you start a reaction, the substrate is changing. Because if you had 10 molecule of substrate, some of the substrate molecule will bind with the enzyme. As a result, the substrate amount will be decreased because it is converting into product. Substrate is converting into product means substrate is decreasing, means substrate is changing. This is a problem because the substrate is changing. If the substrate is changing and you are going to study the rate of reaction with this kind of situation where the rate is changing, then there will be a great complexity. We want to get rid of this situation. We want such a situation where the substrate is not changing. I repeat, because the substrate is changing, so we cannot develop a proper relation between the substrate concentration and the rate of reaction. If you want to get a proper relation between the substrate concentration and the rate of reaction, you need to make the substrate concentration constant. You do something that substrate is not changing. This is a problem. This is a big problem. In order to avoid this problem, we are using initial velocity or initial rate. Did you get that? I know, I'm damn sure that you got the idea that what is the purpose of using the initial velocity. The purpose of using the initial velocity or the initial rate is to get the substrate concentration constant. Now a student sitting in front of me will say, sir, how is it possible that substrate concentration is constant? Actually, I would like to give you one example. If you have, I'm going to erase this. I don't need it. If you have $10 or 10 rupees and you take out only $1 or 1 rupee out of this 10, then $9 or 9 rupees will left behind. This 1 rupee has a very significant value now, because you are taking it from 10. It is a great amount. 1 is relatively a great amount in comparison to 10. But if you take $100 or 100 rupees and you take only 1 rupee or $1 out of 100, the value of 1 becomes a little bit small as compared to that 100, because 100 is very large number, and in comparison to this 100, 1 become more and more smaller. If you take 1,000, lakh, million, I suppose take $1 million or 1 million rupees. Now you take 1 rupee out of this 1 million. If you take only 1, this 1 is almost negligible. If you take 1 rupee out of 1 million, people will say nothing happened. The amount is almost same. We say this amount is almost same. If not almost, we use this word like this, almost same. Means you take out $1 from it, it is almost 1 million again. So we can say almost, it is now again 1 million. So this is a situation. This is a situation where something is decreasing from it, something is emitting from it, still its amount is same. This is a kind of situation that you have to accept. In case of enzyme reaction, we have, let's suppose this is these are enzyme 1, 2, 3, 4, 5, 6. In reality, inside our body, enzyme concentration is very small, very small concentration. So if we take a large amount of substrate, 1, 2, 3, 10, 100, 1,000, lakh, 1 lakh, million, billions, million molecules. So the black dots represent substrate, very high. A large amount of substrate is there, and we have very small amount of enzyme. Okay, if the reaction is allowed to start, some of them, out of this huge number of substrate, only some of the substrate will come and attach at the surface of the enzyme. Reaction will start. The substrate concentration will be supposedly constant in relation to this very small amount of enzyme. That is why we are using large amount of substrate just to make sure that the reaction is going on, still the substrate is constant. And that is the problem that we had in the beginning. And now what we did, we just use large amount of substrate. Now the substrate is now constant. Now you can make a very good relation between what? Between the rate of reaction and the substrate S, because the substrate is constant. Do you know this kind of reaction where substrate is high and the enzyme is very less, how much time will it take? It will take very less time. So we will study this kind of reaction within the first 60 seconds. That is why It is only possible that this kind of reaction is happening in the first 60 seconds, in the first minute. So as a result, we use initial rate or initial velocity, means the rate of reaction in the first 60 seconds. In the first 60 seconds, in the beginning of the reaction, a small amount of the enzyme which is available will react with the substrate. Substrate is a large amount of substrate is there, but only the required substrate will react with the enzyme in a period of what? In a period within the 60 seconds. Maybe it is 10 seconds, maybe it is in 20 seconds. Whether it's taking 10 seconds, this will be our initial velocity. Whether it's taking 40 seconds, this is again our initial velocity or initial rate. So this is the reason why we are using initial rate for the enzyme, just to make sure that only those enzyme catalyze a small amount of substrate out of the huge number of substrate, so that the substrate is constant. Once the substrate is constant, a very good relation can be made between the substrate and the rate, because the whole lecture is about the rate of reaction and the substrate concentration. So this was the first idea that we cleared, why we use initial velocity. Now come to the next, that is maximum velocity or Vmax. What is this? Come to this example. Now I'm going to draw a graph. Before we go to the graph, I will tell you something from the same example, that let's suppose we had 3 substrate molecule, and when these 3 molecules were catalyzed, the reaction become 3. If I use 4 substrate, 4s mean 4 substrate, then in the first second, let's suppose in first second, these 4 substrate molecule will be catalyzed. And how? These 4 enzyme will be used. 1, 2, 3, 4. These 4 enzyme will be used, and we will get 4 molecule per second. The reaction is increasing. Do you remember in the beginning the reaction was 2 molecule per second, then 3, now it is 4. The reaction is increasing. If you use 6 substrate, what will happen? If you use 6 substrate, let's suppose it is just the beginning now again. If you use 6 substrate, one substrate will be attached at this enzyme, other will that and this and this and that. Okay, out of the 10 molecule enzyme, 6 enzyme will be utilized, 6 substrate will be converted into product, and the rate will become 6 molecules in 1 second. So the rate of reaction is now increased from 4 to 6. Now if you increase the substrate concentration from 6 to 10, now you have 10. You are again using the same amount of enzyme. Again, new experiment, you started a new experiment. Again, you have a fixed amount of enzyme, a constant amount of enzyme. 10 enzyme you have, 10 substrate you have. Now what will happen? The 10 substrate will attach at all the available 10 enzyme. The rate of reaction will become 10 molecule per second. You are getting this? So the 10 molecules per second is now called the maximum velocity or the maximum rate, because why? Because if in this situation where you have 10 enzyme, in this situation, if you increase the substrate from 10 to 11 or 12 substrate, the reaction rate will become 10 per second. The reaction will not increase to 12. You know why? Because if you had 10 substrate molecules, you brought 2 substrate molecules more. You brought 2 more, okay, to get 12. Out of the 12 substrate molecule, 10 will be bind to the 10 enzyme. 10 substrate, 10 enzyme. What will happen to these remaining 2 substrate molecules? These will not be catalyzed until and unless an enzyme gets its job and it is free to attach with it. So this time again the rate of reaction will become 10 molecule per second. Although you had increased the substrate from 10 to 12. If you increase the substrate again and again and again and again and again, the rate of reaction become fixed, 10 molecule per second. This is called the maximum speed of reaction of the given reaction. So we called it what? The maximum velocity of the enzyme. I will explain this on the graph now. Let's suppose we have a graph between the x-axis and y-axis, between the substrate and the rate of reaction. 2 substrate, 4 substrate, 6, 8, 10, 12, 14 substrate. Speed is 2, speed 2, 3, 4, 5, 6, 7, 8. Let's suppose you have used 2 molecules, so 2 molecule of substrate, and that time you had speed of 2 molecule per second, and then you increase the substrate from 2 to 3, because here you have 3. When you use 3 substrate, the reaction you will got here means now this dot is coinciding with 3, so the speed is now increased from 2 to 3, and then 4, and then 5. As you are increasing, look, this dot, if you draw this dot down here, means at the substrate concentration of 4, you have a rate equal to 5 or 4. This is actually, I can write it 4 just to make sure, to get the idea clear. So each dot can be traced down and towards this backside at x-axis, at y-axis. At x-axis means 4 substrate molecule, at y-axis means its speed is 4 molecule per second. Now if you combine these dots with each other, you will get a straight line. This straight line shows that the rate of reaction is increasing as you are increasing the substrate. Reaction is increasing. This line will be increasing and not that much as straight. Slowly it becomes curve, not that much straight. Initially the line will become little bit straight, then it become curve like this, not that much straight, and then curve and curve and curve. This curve shows what? Initially there was a straight line. The curve shows that still by increasing the substrate concentration, the rate is increasing. The curve shows what? By increasing the substrate, the reaction is increasing, because look, this is 4, 6, 7, 8, 9 and so on. But the reaction is not increasing in that much speed as it was in the beginning. This is just mechanistic studies of the enzyme. It is the reality. Whenever you trace a reaction, and you will see the graph like this, initially straight line and then become a curve. This is called as hyperbola, hyperbolic curve. Up to this point, the reaction is increasing, and then another stage will come that the line become almost straight, means parallel with x-axis. It is not going up. This line was going up, but now from this region, if I bring it down, means at the substrate concentration of 10, we reach to the maximum height. If you bring this point and attaches at the y-axis, you got speed of 9. The maximum speed that we got is of 9. We can't increase our enzyme speed above 9. Whatever substrate you add, nothing will, because at substrate 12 substrate, same speed, 14 same speed, 15, same speed. If you increasing the substrate concentration, the speed will remain same. The line is not going up like this, but the line is initially straight, slightly curved, and then go parallel with x-axis. Parallel. The two lines are now parallel with x-axis with each other. This situation is called saturation. This situation is called what? Saturation. This situation is called saturation. What happened? Why this happened? Means all the enzyme that we had, 10 enzyme we had, all the enzymes are now occupied by the substrate molecule, 10 substrate molecule. Now this situation is called enzyme saturation or steady state. It is also called what? Steady state. This is also called steady state condition, where the line become parallel with x-axis. And you know, this line that we got here, it come to us after the maximum rate. So we can say that by increasing the substrate, the rate of reaction also increases, but up to this limit, up to the 10 substrate concentration, the rate reached to 9. After the 10, we did not notice any further increase in the rate of reaction, but the rate of reaction remained almost constant. This reaction will be proceeding, going and going and going and going. Of course, time will also be consuming 1 minute, 2 minutes, 3 minutes, 15 minutes, 20 minutes, but the reaction will be like this. As far as you have large amount of substrate, once all the substrate utilized, we have zero substrate, but still we have enzyme will be available with us when all the enzyme are consumed, all the enzyme. Of course, the available substrate were catalyzed into, converted into product. More substrate will come, they will be catalyzed into product. More substrate will come until all of the substrate molecules, they are consumed. Now come to the order of the reaction. What is mean by this order of the reaction? If you want to study the order of the reaction, I would like to tell you one thing more, that these two reactions, enzyme and substrate, they are going to combine with each other to get enzyme substrate complex. Enzyme substrate this is a reversible reaction. Okay, this is a reversible reaction. Reaction 1, second reaction is enzyme and substrate complex. This is enzyme substrate complex. Enzyme substrate complex is dissociating into enzyme and product. This is also a reversible reaction. The two reactions are reversible. Okay, but one thing that you should know is that first reaction is very fast. This is very fast reaction. Enzyme substrate combined to get enzyme substrate complex. This is very, very, very fast. But the second reaction, where enzyme substrate is converting into product, this is what? This is a slow step. In chemistry, we know very well that slow reaction, the slow step is always the rate determining step. I would like to write here. Slow step is always the rate determining step. You should note this, rate determining step. So if we are asked that which one of these two reactions is controlling the rate of reaction, your answer will be this reaction number 2. Why? Because this is slow step. In organic chemistry, you may find a multi-reaction, a 3 reaction, 4 reaction, 5 reaction in a series. So you will have to find the slowest reaction rate, the slowest step. The slowest step will be the rate determining step. So this is our slowest step. Here, now I would like to, that's a reversible reaction. In this reversible reaction, if I start now, this was a scenario where we used a lot of substrate. Now the scenario is changed, just like we studied in the graph. In graph, I started from small amount of substrate from 2, and then I go to 4, and then I went for 6 and 8 and 10. Means we had in the beginning we had small substrate molecule, and then we are increasing the substrate from 2 to 4 to 10 like this. In the beginning we have loose substrate, right? Loose substrate molecule like this. We have enzyme E, lot of enzyme molecule. We have many enzyme molecule. Okay, 6, 7, 8, 9 and 10 enzyme we have, and I have very loose substrate, only 2 substrate molecules. In this kind of reaction, where you have very less substrate molecule, if you have less substrate molecule, means this side is very small, side is already small. If I increase the substrate molecule, from 2 to 3, or from 2 to 4 substrate molecule, then this side will become increased. In a reversible reaction, if you increase one side, as a result the reaction will go on that step. If you increase something on that side of the reaction, the reaction will go at the reverse step. This is a natural fact. You are increasing the substrate, so this side is increasing. As a result, your reaction will shift towards the right side. The reaction will shift towards the right side, means more enzyme substrate complex will be formed. What happened? More enzyme substrate complex will be formed. And now you come to the second step. This is our rate determining step. Rate determining step means if you have more enzyme substrate complex, then the reaction rate will be increased. If you have less enzyme substrate complex, the reaction rate will decrease. Now, in simple words, by increasing the substrate, because initially substrate were very less, you increase the substrate. As a result, more substrate combined with enzyme, more enzyme substrate complex formed, and more enzyme substrate converted into enzyme product. This is a situation, you can write, this is a situation where the rate of reaction is depending upon the substrate. The rate of reaction is depending upon the substrate. Such kind of reaction where the rate or the speed is dependent on the reactant, substrate is a reactant, is called first order reaction. First order reaction. So first order reaction is possible at which stage? At low enzyme concentration. This is a very special point. I would like to add stars. If you are asked which time the enzyme will be doing first order reaction, you will say initially in the beginning when the substrate is low and you are increasing the substrate in the beginning, then the reaction will follow first order. First order is that reaction where the speed is dependent on the substrate concentration. The speed or the rate is dependent on the substrate, because you are increasing the substrate and more ES will be formed and product will also be increased. Okay, for what time will you do like this? For which time you will increase substrate? You know there is a limitation. Do you remember this? You can increase the substrate from 2 to 4 to 6 to 8 to 9 to 10. There will be a time when you increase the substrate from 2 to 10, that all the substrate will bind to the all enzyme. Mean you will be having maximum enzyme substrate. If you have 10 enzyme, you have 10 substrate, so 10 substrate, 10 enzyme. maximum speed will be there, maximum ES will be there, and you will get maximum product. What will happen if you carry on further increasing the substrate? You are not stopping. You know that at 10 substrate the reaction was maximum, but you still continued, keep on increasing more and more substrate. What will happen? If you increase the substrate further, do you think the rate will increase? No, the rate will be constant. So at that stage, you had used a large amount of substrate, and this time the rate of reaction is not depending on the substrate S. Another scenario will come where the rate of reaction will not depend on the substrate. You are increasing the substrate, you are adding more and more substrate, but the reaction is not going up. The reaction is not going, the speed is constant. This stage, which is called saturation, my dear students, this stage which is called saturation, where all the enzymes are occupied by the substrate. This situation is also called steady state. At this stage, at this straight line, you have the maximum amount of enzyme substrate complex. I already told you that I am going to add a star point here, enzyme substrate complex. This is very, very important. Enzyme substrate complex is also controlling our rate of reaction. You have the maximum number of enzyme substrate complex. Maximum number of enzyme substrate complex give us the maximum rate. At this stage, if you are increasing the substrate concentration, no further speed is possible. This kind of reaction, reaction is still going on. Reaction is not stopping, reaction is still going on. This kind of reaction is called zero order reaction. So I am going to write, this was stage 1 at low, now stage 2 at very high, not high, at very high substrate concentration. What will happen? Saturation takes place. No further increase in the rate of reaction. Saturation and constant rate of reaction. This is called zero order reaction. Zero order reaction is that reaction where the rate of reaction is not depending on the substrate. So we have two type of reaction. First order, zero order. In first order reaction, the reaction rate is depending on the amount of substrate. In zero order, the rate of reaction is not depending on the substrate. So this was the idea that we got from the rate of enzyme reaction. And that was enzyme substrate complex is the key to understand the kinetic behavior. Order of reaction discussed, graph discussed, maximum velocity, initial velocity, each and everything was discussed in this lengthy video lecture. I would like to give you a small summary about this video lecture. And this video lecture, we started the lecture with the rate of enzyme reaction. What is the rate of enzyme? And then we came to the word enzyme kinetic. We studied what is enzyme kinetics. We saw that different kind of parameters controlling the rate of reaction. Among all these parameters, one of the most important parameter we picked, that was the substrate concentration. The whole lecture was in between the two things, substrate concentration and and the rate of reaction. The whole lecture was in between the rate of reaction and the substrate concentration. By increasing the substrate or decreasing the substrate, what happened to the rate of reaction? The whole lecture was about this. We studied what is initial velocity or initial rate, and then we also studied why we use the word initial rate and initial velocity. This was also discussed here. Then we discussed what is mean by the maximum velocity? Maximum velocity was explained in this example as well as by the help of the graph. In both the graph and this example, we got the maximum velocity. Then we took enzyme substrate complex, and then we saw that when enzyme start reaction, we have two reactions. The first reaction is that when enzyme is combining with substrate to get the enzyme substrate, this is reaction number one. This is very fast reaction. It is not controlling the speed of reaction. But the second reaction, where the enzyme substrate complex is breaking down, is dissociating down into enzyme product, this is the slow reaction. This slow reaction is actually controlling the rate of reaction. Then we saw that in a reversible reaction, where reactant can convert into product, the product can convert into reactant. A reversible reaction, if you increase one side, the reaction will go to the right side. If you increase the left side, the reaction will go to the right side. If you increase the right side, the reaction will go back to the left side. So what happened? We started the reaction with small amount of substrate. Then we gradually increase the substrate from 1 to 2 to 3 to 4 to 5 to 6. We did not use a huge amount of substrate at once, but we started the reaction from 0 to 1 to 2 to 3. And then we saw that by increasing the substrate, what happened? More substrate will combine with the enzyme, more ES will be formed. More ES will be formed, so it will be more high speed. So this line which you see here actually tell us more speed, because in this line more enzyme substrate complex are formed. And then in the beginning, this was a first order reaction because the rate of reaction was depending on the substrate. You were increasing the substrate, the reaction rate was also increasing. After some time, another situation came that we had a maximum rate where further increase in the rate was not possible. This situation was called the saturation or the steady state condition. At this stage, no further increase in the rate was possible. We called this reaction as a zero order reaction. I hope you got this whole video lecture. You can pause the video from any point and repeat it again and again if you got the lecture. In the next video lecture, I will come with the same idea, but we will discuss Michaelis-Menten equation. Why Michaelis-Menten equation came to us, how it is derived. Even I would like to derive the Michaelis-Menten equation in my next video, inshallah. So take care, bye bye.